Hi everyone, welcome to the last video lesson for the school year. So in this lesson, you're going to learn how to simplify complex fractions. So for when you divide fractions, don't forget you actually end up multiplying them. So you keep the first fraction, which is 3 over 5 in this case, and then you change division to multiplication, and you take the reciprocal of the fraction, the denominator. So this is 4 over 5, then make it 5 over 4. So then when you cross multiply tops with tops and bottoms with bottoms, 3 times 5 gives you a 15, and 5 times 4 gives you a 20. But then you can simplify this because 5 goes into 15 3 times and 5 goes into 20 4 times. So then this division problem becomes 3 over 4, or 3/4. Okay, so the point is just multiply by the reciprocal. So let's use that same idea with the next example. So we have 3 over x and divided by 8 over y. So then what I'm going to do is I'm going to keep the 3 over x, and I'm going to take the reciprocal of 8 over y. So now this becomes y over 8, and then multiply across the tops and across the bottoms. So 3 times y is 3y, and x times 8 is 8x. And this is the answer to this example. So for the next example, we have 1 over x plus 10 divided by 5 over x squared minus 7. But notice that this is a difference of squares. So then this numerator, this part stays the same. So 1 over x plus 10 times, I'm going to reciprocate this one, but I'm going to factor it out using the difference of squares. So then this one is factored as x minus 10 times x plus 10 over 5. But then I'm going to cross out x plus 10 and x plus 10 because we have that factor in common. So then this simplifies to 1 times x, which is x, 1 times negative 10, that's minus 10, over 5. This became a 1, so you're just multiplying 1 times 5. So this is the final answer for this problem. So notice today we're not listing restrictions. Okay, so do not worry about restrictions for any of these problems today. All right, to the next part, go ahead and cross this out and write down simplify each expression, because this will be easier to understand and also easier to explain. Okay. So what I'm going to notice first is that this is 1 over x, this is 3 over 1. So then I need to have an x on in the denominator for this 3 instead of a 1. So that tells me that I need to multiply by x over x so I can have the same denominator in the numerator. Okay, and this is 4 over 1. This 5 has an x under it. So let's multiply this by x over x. So then once we multiply by x over x, then this becomes 1 plus you multiply 3 times x, that gives you 3x. Over, now they have x in common as in the denominator, and then divide that by, we have 5 plus 4 times x is 4x, and now they both have x in the denominator. Okay, so now we're back to a problem similar to this one here. So I'm going to change this to multiplication. So I'm going to keep the numerator as it is, which means, and I'm going to switch them around. So I'm going to bring the x to the front. So that means it's going to be written in standard form. So 3x plus 1 over x times, changing this to multiplication, I'm going to take the reciprocal of this. So this is x over 4x plus 5. And notice I also switched this 4x and the 5 so that this is in standard form. But then notice that we have x and x in common, so we can cross out the x's. So in the end, the answer is 3x plus 1 over 4x plus 5. And then this cannot be simplified any further, so that means this will be our final answer for this problem. So I'm going to go back and box it in. But if there's a GCF, you always factor out the GCF. Okay, so that's all for example number 1. Example number 2, I see that the numerator, there's only 3 over y, but the denominator, this one is to be implied over 1, but this one's a 2y, so that means I need to multiply this first term by 2y over 2y. So that's what I'm going to do next. So then this numerator stays the same. It's 3 over y. That's a monomial. but the denominator is a binomial. So then 2y times 1 is 2y, and then we just keep that minus 1. Now we have the same denominator in both, so that means this is over 2y. Now let's keep this first fraction, which is 3 over y, and change the operation to multiplication and take the reciprocal of this denominator. So then 2y goes to the top, and let's see, 2y minus 1 goes to the denominator. Okay, so then as you can see, this y and that y reduce, so we end up just multiplying 3 times 2, which is equal to 6, over, this becomes a 1, so we're just multiplying 1 times 2y minus 1, which is 2y minus 1. And this one cannot be simplified either, so I'm going to box in my answer, letting you know that I'm finished with this problem. Okay, all right, example number 3. So for this one, notice that this is x in the denominator, this is y, so that means we multiply the 2 over x by y, so we have y on this one, so y over y, and this one does not have the x, so we multiply by x over x, so we have the same denominator. So the denominator is, the least common denominator for the numerator is x times y. Okay, so then the denominator for this one, this bottom here, this bottom fraction, this has y, this is x, which means this one does have the x, so let's multiply by x over x. And this one has the x but doesn't have the y, so let's multiply by y over y. So then once we multiply, we're multiplying 2 times y, which is 2y. And this we're multiplying by x, so 4 plus 4x. 4 times x is 4x. And then denominator of this one, okay, you're multiplying y times x, which is x, y, and this one is also y times x. So then we have the same denominator of x times y. Okay, so then numerator, let's go to the second fraction on the bottom. So for this one, I'm multiplying, let's see, by x. So multiply x times 3, that gives us 3x. And then this one is we're multiplying by y, so minus 1 times y, which is y. But then denominator of this fraction is x times y, and this is x times y again. So then denominator is x times y. Okay, so then what we do next is we change this operation to multiplication. I'm going to keep the numerator, this part here, as it is. And I'm going to rearrange so that this is written in standard form. So that means 4x goes first, and then plus 2y. Denominator of this one is xy. And then change division to multiplication. So I'm going to write xy on the numerator. So take the reciprocal of this fraction. And then denominator is 3x minus y. So then, as you can see, this one and this one we can cancel out. There's a GCF here of 2, so I'm going to factor it out. So then we have 2 times 2x plus y over, we have in the denominator 3x minus y. Now this cannot be simplified any further, so this is my final answer. And I'm just going to add a note here. And that is the final answers. My answers must be factored completely. Okay, so you must, if there's a GCF, then factor it out. If it's factorable, then factor it out. So with that said, let's go to example number 4. So for example number 4, this 7 is implied to be over 1. And this one is okay. We only have one monomial divided by a binomial, so we don't have to do anything to it. But for this one, we must have x minus 4 under that 7. So then multiply by x minus 4 over x minus 4. So we have the same denominator. So then keep this part alone. We don't have to do anything to it. So 3 over x minus 4. And then denominator. This one here, you're multiplying 7 times x minus 4. So distribute 7 times x. It's 7x. And 7 times negative 4. That's minus 28. But then we have a minus 2 here. Okay, so there's a minus 2. That's this part. Now they both of these expressions have x minus 4 in the denominator. So then combine like terms. So for this one, this is equal to, leave this one as it is. So 3 over x minus 4 divided by 7x minus 28 minus 2. This is 7x minus 30 over x minus 4. And now let's take the reciprocal of this one and change this operation from division to multiplication. So then I have 3 over x minus 4 times, instead of division, this is going to get flipped. So this goes to the top and this goes to the bottom, or numerator and denominator. So x minus 4 over 7x minus 30. And as you can see, we can cross out x minus 4. So then in the end, the answer is 3, which is coming from here, over 7x minus 30. Now this one, there's no GCF because 7 is a prime number and it doesn't go into 30 evenly. So then I'm going to box in my answer. And again, we're not listing restrictions today. Okay. All right, last example for the school year. Yay, you should all be happy. We're done with this. So then notice that this 3 is over 1. We need to have an x under it. So then multiply by x over x. And this one is, again, similar to the last example or the previous example, example number 4. We don't have to do anything to it, okay? So then leave the numerator as it is. So 2 over x plus 7 divided by, you're multiplying this 3 times x. So that becomes 3x. And we didn't have to do anything to this one because it already has the x under it. So then this is 3x plus 1. Now they have x in common as a denominator. So once we get to this point, this is when we keep change and flip. So leave or keep 2 over x plus 7 as it is, change division to multiplication, and let's take the reciprocal of this one. So this is x over 3x plus 1. Okay, in this case, we cannot cancel anything out or cross anything out because there is nothing that we can see that they have in common. So what we do instead is we multiply 2 times x, which is 2x, and then denominator, my advice is leave it in factor form. Okay, final answers must be factors. So I am not going to multiply here. I'm just going to write down x plus 7 times 3x plus 1, and yay, we're done, finally. I hope you guys enjoyed this video. I'll see you in class. Thank you for watching. Bye-bye.